Humans have a relatively small range of temperatures that we find suitable. Go any lower than about 32 degrees Fahrenheit or 0 degrees Celsius, and most people don't go outside without a billion layers on them. That is, unless you live in Wisconsin. Likewise, any temperatures above 95 degrees Fahrenheit or 35 degrees Celsius leaves us cranking the AC on or heading to the pool. But nature is not dependent on these temperature ranges, and thus can leave them whenever it pleases. And in some cases, it can go so mind-bogglingly far outside of them that we question whether it's even worth visiting the places where it happens. So with that in mind, just how hot and cold can it get? Now before we answer that question, I'd appreciate you to like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so to begin, let's look at the hottest temperatures ever recorded. You would expect the hottest temperatures to be right on the equator, but this is not the case. Generally, the equator itself is hot but humid, and the moisture helps lower the overall daytime temperatures. Instead, the hottest temperatures on Earth are found in the bone-dry deserts in the subtropics, where intense sunlight and little cloud cover can cause temperatures to skyrocket to incredible levels. However, this record is shrouded in a fair amount of controversy and uncertainty, and it all has to do with the reliability of the weather stations in these locations and the people running them. Up until 2012, the official record for highest temperature on Earth was 136 degrees Fahrenheit or 58 degrees Celsius in El Azizia, Libya, set in September 1922. However, the World Meteorological Organization invalidated this record in 2012. Why? Well, there are very specific standards for how temperatures are measured, with the location and conditions of measurement needing to be consistent and absent any artificial interference. This reading in 1922 fails to tick any of these boxes, with the thermometer being placed over a tarmac which inflates air temperatures due to increased sunlight being absorbed, the thermometer itself not being that good, and the readings being taken by an inexperienced observer which, among other things, may have inflated the recorded temperatures by several degrees due to reading the thermometer itself wrong. With all these considerations, this record was thrown out and replaced with an 134 degree Fahrenheit or 56 degrees Celsius reading from Death Valley in July 1913. However, this reading is also being heavily scrutinized, as many meteorologists have pointed out a discrepancy between this reading and other readings in the region on the same day. Notice a pattern here. Yeah, generally temperature records from an era before satellites and 100% standardized record keeping tend to be unreliable. If you look at the modern era, the hottest temperature recorded is accepted to be in 130 degree Fahrenheit or 54 degrees Celsius reading, also at Death Valley, achieved twice in 2020 and 2021. It is worth mentioning, however, that these readings are merely taken at weather stations that people have set up, and it is not currently possible to map the air temperature for every inch of Earth's surface. As a result, it is very likely that pockets of land deep in deserts like the Sahara have achieved even more extreme temperatures that we don't know about. But all of this is merely what's found on Earth. Can you crank it up further? Well, the hottest planet in the solar system is Venus, whose surface reads at a whopping 864 degrees Fahrenheit or 462 degrees Celsius, primarily thanks to an atmosphere made almost entirely from carbon dioxide that traps the sun's heat extremely effectively. The surface of the sun itself reaches an incredible 10,000 degrees Fahrenheit or 5,500 degrees Celsius, which is hot enough to vaporize just about any element. But the absolute hottest temperatures that you can find are not the surface of a star, but deep inside the star's core. Here, the pressure is so great that it heats plasmas to levels that are able to sustain nuclear fusion, the outward force of which creates an equilibrium that stabilizes the star. How hot the core gets depends on which element is being fused, which in and of itself depends on the type of star. Stars like our Sun that fuse hydrogen in their cores are heated to about 27 million degrees Fahrenheit or 15 million degrees Celsius. But much more massive stars that fuse heavier elements have cores that are several billion degrees. But there is one type of object in the universe that gets so unbelievably hot that it's hard to even comprehend it. We're talking about neutron stars. These stars are the dead remnants of a star that went supernova, which in and of itself is a violent explosion that tears the star apart and casts its remnants across the galaxy. Neutron stars happen when the core of the star gets compressed into a space no bigger than your average city, which, keep in mind, can be twice as massive as the sun. This process of compression into a tiny space heats the neutron star enormously, potentially reaching as high as 2 trillion degrees Fahrenheit or 1 trillion degrees Celsius, but they radiate so quickly that it only takes a few years for it to cool to a much more comfortable 1 million degrees. In theory, things can get significantly hotter, with the maximum possible temperature believed to be about 10 to the 32 degrees, a temperature our universe may have come close to immediately after the Big Bang. Suffice to say, I don't think any of us want to experience that kind of heat anytime soon. Okay, but what about extreme heat's quite literally polar opposite, extreme cold? Fortunately for us, unlike the record for extreme heat, the coldest temperature record on Earth is a much more open and shut case. The official record, as certified by the aforementioned WMO, is negative 128 degrees Fahrenheit or negative 89 degrees Celsius at Antarctica's Vostok station in July 1983. The recency of this measurement, combined with the fact that it was taken at a reputable scientific station, helps make the record legitimate. But in a world where temperatures just a handful of degrees below zero are considered bone chilling, how on earth does Antarctica get this cold? Well, there are two factors at play here. One, the obvious location near the South Pole helps to cool temperatures. But unlike the North Pole, which is primarily sea ice, Antarctica is a gigantic ice sheet several miles thick in spots. And as a result, Antarctica's average elevation is about 10,000 feet or 3,000 meters above sea level. Everyone knows that temperatures cool as elevation rises, and the poles are no exception to this real rule, which leads to some truly cold temperatures. Vostok itself sits at about 11,500 feet or 3,500 meters above sea level, and is about as far from the ocean as you can get in Antarctica. However, the fact that Antarctica is so remote and so high in elevation means that there are undoubtedly more locations where temperatures can plummet further that just aren't near any weather stations. In fact, satellites have determined that some areas of Antarctica have potential to get several degrees colder due to even higher elevation. But once again, Earth is not the final frontier when it comes to extreme cold. The coldest planet in our solar system is Uranus, which is a frigid negative 360 degrees Fahrenheit or negative 220 degrees Celsius, which is about what the melting point of oxygen is. However, this doesn't even come close to one of the coldest things around, the universe itself. As the leftover radiation from the Big Bang has fizzled out, the universe has gradually become colder over billions of years, and currently has an average temperature of about negative 454 degrees Fahrenheit or negative 270 degrees Celsius. Unlike extreme heat, there is a limit to just how cold something can get, absolute zero, which is negative 459 degrees Fahrenheit or negative 273 degrees Celsius. This limit exists because at this temperature, there is absolutely no energy in a particle, so they stop moving completely. It is currently believed to be impossible to actually reach this exact value for a variety of reasons, but you can come extremely close. Under certain conditions, it is possible for an object to naturally dip below the background temperature of the universe, with the Boomerang Nebula being just 1 degree above absolute zero. In the laboratory setting, we've gotten even closer. The world record for coldest temperature in the lab is just a billionth of a degree above absolute zero. Now that's a temperature that you want to pack a layer for. Or 2, or 20, you get the point. So what can we take away from this? Well, the range of temperatures that humans can survive and turns out to be infinitesimally small when compared to what our Earth can produce, let alone the entire universe. As a result, we should count ourselves very lucky that Earth's climate is even remotely hospitable, because in 99% of circumstances, it could be much worse. As always, I'd appreciate you to like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.